value, guys, is the distance from 0. So absolute value is always positive because we're talking about a distance from 0. Okay. Don't worry about this formal definition. Let's look at actual problems here. Okay. So graph each on a number line. So the absolute value of x equals 2. So you want to ask yourself, what numbers are 2 units from 0? What do you think? 80. Yeah. Yeah. 2 and negative 2. Okay? So positive 2 is 2 away from 0, right? A distance of 2 away from 0. And so is negative 2, right? So if you put 2 in, the absolute value of 2 is 2. And if you put negative 2 in, the absolute value of negative 2 is 2. Anything that's negative is positive. All right? What two numbers, or actually more than two numbers, what numbers are less than or equal to 3 units from 0? Monica?
1, 2, and 3, and negative 1, 2.
Yeah. So we could go, it's less than or equal to 0, right? So from here to here, that could be 1 unit away, 2 units away, 3 units away, or we could go here to here. What I want you guys to do is branch this out into 2 answers, okay? So you're going to have the absolute value of x is less than or equal to 3. What we do is we get 2 different answers here. We have the positive ones and we have the negative ones that also work, right? Because negatives change to positives. So the first thing you're going to write is x is less than or equal to 3. It's the exact same thing, but without the absolute value bars, okay? So that's part of the solution, the values that are less than or equal to 3. The rest of it, we switch the inequality. So it was less than, it goes greater than, and negative. So you flip and you make that number negative, okay? So we also have answers that are greater than or equal to negative 3. So that means my solutions go from positive 3 to negative 3. So your number line should be shaded in between, okay? Because this one says less than positive 3, and this one says greater than or equal to negative 3. And so we shade in between those range of numbers. Yeah. Yeah, shade all the way. There's not really a break at all because 0 is an answer, okay? So why does this work? Again, if I plug negative 2 in, the absolute value of negative 2 is 2, and 2 is less than or equal to 3, okay? What if we have greater than? So the absolute value of x is greater than 2. So anytime you have absolute value, you're going to branch it out, and we get x is greater than 2, so it stays exactly the same for the first one, except you drop the absolute value bars. And then we do x is less than negative 2. So we flip it on the negative side. And those are my 2 solutions. But this one looks different than the last one. So for this one, we have x is greater than 2. That means open circle on 2. Greater than 2 is shade to the right. Okay. And then I have x is less than negative 2. Open circle on negative 2. And shade less than. So this one, my arrows pointed out instead of in. All right? We call these OR graphs when your arrows point out. And we call these AND graphs when you shade in between. Okay? Anytime you have greater than, get it? You have an OR graph. It's going to point out. Anytime you have less than, you're going to have an AND graph. So let's try some more that have a few more steps. So we have negative absolute value of x plus 3 is less than or equal to negative 1. Before you branch it out into the positive and the negative, you have to isolate the absolute value. Okay, that's always the first step. Get the absolute value of x by itself. So we need to get rid of this plus 3 first. So I'm going to subtract 3 from both sides. So now I have negative absolute value of x is less than or equal to negative 4. Okay? We still have that negative sign in front of x, which we need to get rid of. All right? You can get rid of it by multiplying both sides by negative 1 or dividing both sides by negative 1. So I'm going to divide by negative 1 so I can cancel the negative sign and divide by negative 1. Now, anytime we're doing inequalities and we divide by a negative, what do we have to remember to do? Flip the inequality sign. So now I have the absolute value of x, and we're going to flip this because I divided by negative 1 so that it's greater than or equal to. Now I have negative 4 divided by negative 1 is 4. You always have to have a positive here, or else you have a special case, which we'll talk about, okay? So if there's a positive, then you branch it into the two answers that we were just talking about, right? So the first one stays exactly the same. X is greater than or equal to 4. And you drop the absolute value bars. And the second one flips it on the negative. Okay, and this is how I get the two parts of my answer. So x is greater than or equal to 4. Evan, is that solid circle or open circle? Okay, so I'm going to start with this one. Solid circle on negative 4. And Ella, shade right or left? Good. This guy points to the left, right? So I'm going to shade to the left. All right. And Nate, open or close circle on positive 4. Okay, closed circle. So closed circle on 4. Doing this one now. And it says greater than here, so Corey, which way do I shade? Good, we would shade to the right. Notice I started with greater than and ended with an or graph, which points out. Okay. All right, let's try the absolute value of x minus 5 is less than 3. So go ahead and write that down. So we always isolate the absolute value first. So Micaiah, what's the first step? Yep, we're going to add 5 to both sides. So we get the absolute value of x is less than 8. Again, this number has to be positive, or else you have a special case, which we'll talk about. So the next step is to branch it out into your two different solutions, the positive one and the negative one. So Lucas, how do I write the first one, the positive one? Yep, x is less than 8. Stays the same, but you drop the absolute value bars. And Monica, how do I write the negative one? Very good. You flip it on the negative one. And now we're going to put it on the number line. So Isaac, open or close circle on 8. Good. No line underneath, so open circle. Okay, this says less than. And so Bethany, which way do I shade? Good. We're going to shade left. Don't shade all the way yet. Okay, Ben, open or close circle on negative 8. Okay, open circle on negative 8. Says greater than, so Aaron, which way do I shade? Good, to the right. So we're actually shading in between on this one. Okay, again, this one was less than, so think and. Will be an and graph where you shade in between. Okay. All right, negative absolute value of x is less than or equal to negative 4. So we need to isolate the absolute value by getting rid of that negative sign first. So Sophia, what's the first step? Yes, divide by negative 1 on both sides. So we have the absolute value of x. Because we divided by a negative, what do we need to do? Okay, flip it. And we get the absolute value of x is greater than or equal to 4. Now we branch it into our two answers, only because we have those absolute value bars. And I want to see every step on these, okay? So, Dylan, what's the first one? Good, except for you drop the absolute value bars, right? Okay, Jordan, what's the other one, the negative one? Good, be sure you flip it on the negative one. Okay, so Leah, open or close circle on positive 4. Good, we have the line underneath, so closed. And Alex, shade right or left? Good. Okay. And Drew, open or close circle on negative 4. Good. And Nico, shade right or left? Good. Points left, shade left. So we have an OR graph because this was a great OR then. It ended as an OR graph. So all the solutions that work are anything 4 and up and anything negative 4 and down. Okay. Now we have the special cases. Okay, there's only 2 special cases. Notice, first thing that you want to notice, red flags should go off when you have the absolute value of something and it's a negative number, okay? So if you solve all the way down and you isolate the absolute value and you end with a negative number, you don't branch it out, all right? There's not positive, negative. We just want to think about it for a second, okay? So absolute value means distance from 0, which means it's always positive, right? So give me some examples of some positive numbers. Lucas? 100. All right, 100. Okay, 100. Is that greater than negative 3? Yeah. What else is positive? Monica? 14. Is that greater than negative 3? Yeah. Okay. No matter what we plug in, what if I plug in negative 100, but then it says absolute value of that? It goes positive 100, right? So even if I plug negative 100 in, I get positive 100 because of the absolute value bars. So what does that mean? What does that mean if I plug in any number and it works every time? It means all real numbers work. Okay? Everything works. If you plug in negative 1,000,000, because it says absolute value, that's going to change it to positive, and anything that's positive is bigger than a negative number, right? Because it says greater than negative 3, anything is going to turn out to be bigger. So when you guys shade, you shade your entire number line, and you put arrows, because it goes forever, okay? So one of the answers will always be all real numbers if you have that negative sign. The other one, what if we have the absolute value of x is less than negative 4? So let's say I plug in negative 100, right? So you plug negative 100 in, but it says absolute value, so that changes it to positive 100. Is positive 100 less than negative 4? No, right? So whatever we plug in is always going to be a positive number. Are there any positive numbers that are less than negative 4? No. Okay, so this one is no solution. And you would just have an empty number line. Okay, your number line has nothing on it because nothing works. There are no positives that are less than a negative number. Make sense? Those are the only 2 special cases. If you get a negative, it has to be one of those special cases. Sorry. Let me look at it. Lesson 96, difference of 2 squares theorem. So first of all, you guys, there are 2 ways to solve these problems. One of the ways right here, actually anyone know one of the ways to solve x squared equals 25? Drew? Okay, subtract 25. That is one way. What's the other way? And I know where you're going with that. Yeah, Monica? Nope. I mean, you could, but that's kind of the same thing. Setting it equal to 0. There is another way. Yeah. Yeah. Square root both. So this is called the algebraic way, where we just take the square root, right? Now, is x equal to just 5? if you take the square root here. Just 5. That's the only answer. What's the other one? Yeah. So remember that negative 5 squared in parentheses, which is what it would be if you substituted it in, okay, is also positive 25, right? So whenever you do it the square root way, it's plus and minus 5, all right? But the way that we're going to do it today is with the difference of two squares theorem, which is the way that Drew was talking about. So let's try it. So I've got x squared equals 25. So we're going to solve it as if it's a quadratic, which it is. We're going to set it equal to 0 first. So we're going to subtract 25 from both sides. So we get x squared minus 25 equals 0. So now it is a difference of squares, which you guys have seen a whole bunch of. And this factors x plus 5, x minus 5. Okay. And then you set your solutions equal to 0 and solve, which means you get negative 5 for the first one and positive 5 for the second one. Okay, so there's your theorem, which it talks about right there. If P and Q are real numbers, and if P squared equals Q squared, then P equals Q or P equals negative Q. All right, so that's what we just did. Okay, now if it looks like this, okay, all you have is the square root of 16. There's no variable, okay, then your only answer is 4. Okay, because there's no x. So if it says, what's the square root of 16? We're just going to put 4. If it says x squared equals 16, we're going to get plus and minus 4. Okay, so that's the difference of a variable or no variable. How about this guy? What's the square root of 16? But there's a negative in front, so our answer here is negative 4. Okay, 16 does not equal plus and minus 4. Good. So that's what we just talked about, right? The square root of 16 does not equal plus and minus 4. Only if you have this are you going to get plus and minus 4. So if you're solving for a variable, then remember plus and minus, which is what that one is. So there we go. All right, so let's solve each equation. So I'm going to set it equal to 0 first, which means I'm going to move it to the other side so it becomes negative 169. So we're going to factor it. Anyone know what the square root of 169 is, Corey? Very good. Plus 13 and minus 13. So our solutions are negative 13 and positive 13. All right, q squared equals 23. Okay, is there a square root of 23? So we cannot actually factor this one. So we're going to do this one the algebraic way, all right? So we're going to take the square root of both sides to solve it. So q equals plus and minus the square root of 23. Could we have solved this first one the same way? With the square root? Yes. And you would get the exact same thing, plus and minus 13. Okay? All right. Is there a perfect square number for 14? Or is 14 a perfect square number? No. So let's go ahead and do the square root way. So we get W equals plus and minus the square root of 14. Okay? Biggest error, you guys, is people forgetting plus and minus. All right, so always remember positive and negative when you're solving algebraically. That was a really